to the encoding algorithm. And of course, in the end, we end up with a line in the bytecode which says we load bytes. So the byte loading function cannot be hidden easily, which is unfortunate, but there are legitimate uses for the byte loader function, so we don't actually need to hide it. There are many places to hide. The obvious choice would be to hide it in external resources like Flickr images, or, well, there might be data hidden even in this very image, which can be extrapolated during runtime using the bytecode transformation. Yeah. So the tool we've written originally focused on Swift versions up to 8, which only handles ActionScript 2 bytecode, so we implemented the pattern matching described earlier, which is very similar to virus pattern matching. And, well, recently I added ABC bytecode parsing to the tool, so the statistical classification method was able to be implemented. So what else can I say here? Well, you might like to take a look at this particular tool. It has a JSON export, it has, of course, the n-gram analysis implemented, it's got an API, and can be used as a library. And the thing here is, I'd like to present a few ideas we have, which are called random ideas. As a matter of fact, most of the ideas originated from earlier talks at different conferences like DeepSec and another conference in Belgium, where people were asking questions or having ideas about where data could be hidden, how to analyze Swift files. So the very first we could build an interpreter in ActionScript 3 and hide the code to be executed, matching exactly the statistical profile that we calculated earlier with the n-gram method. So the bytecode being loaded during runtime would look exactly like the code of the profile, of the reference profile. Then, of course, we can try to avoid detection by exposing only strings to the constant pool that look exactly like ordinary strings. Like shown before, we can call our variables next ID or ABC, but not AX2318. That would look very suspicious. Then, and that's a very interesting point, we can use conditions set by the browser in order to have an encryption key for a very particular set of targets. For example, if you've got a browser version or a browser string, and you've got a date and time, and you've got an IP address, the DNS name, referrer, a player version, maybe even a time frame in a movie being played. So you can extract all the information, build an encryption key, and use the encryption key to target only platforms which can generate the right encryption key. Then it is possible to use a dynamic tracing by overloading, well, the class, which is displayed here, flash display loader, which happens to include the load bytes method. And the load bytes method is being used to load arbitrary data, as shown before here. Here is load bytes. So it's possible to overload the class that uses load bytes in order to briefly check what we're actually loading after it's being decrypted. Right, more ideas. Well, actually, it's his idea. It would be nice to have a toolkit to have an easy obfuscation, automated obfuscation maybe for payloads. Then recently, just 5 or 6 weeks ago, Adobe released a tool called Alchemy. Now, the Alchemy tool, which is based on the AVM tool, the second virtual machine, happens to implement very, very fast memory operations on byte arrays. So if we try to decrypt or decode our payload in real time, that'd be really, really fast using the new methods described or implemented in the new Alchemy tool. Well, basically it's a compiler or a compiler extension. Then we can really look forward to the Flash Player 10, which is out already, but it may implement UDP or P2P functionality. Will there be any questions so far? No questions? Yep. So, I'll briefly show you the graph again.
Here's the question.
Oh, yes, please.
I saw that code, that with the headline, I don't quite get it. Where did the actual data get into the code? Is it supposed to actually work, or is it just an example?
Could you repeat the question, please?
Okay, that scaped, the one with the head part in it, I don't get how the data actually gets from A to the loader. It doesn't seem to have any place that actually moves. It just seems to be an empty array.
Unfortunately, I'm unable to correctly recognize the question here. So, well, I'm not quite sure what you're referring to, but as you can see, my statistical profiles actually contain real data. They're not empty, and they're being calculated properly, so you can calculate distances between Swift files statistically. I'm not quite sure if that answers the question, but well, we're not dealing with empty arrays at any point.
What did you mean? I mean, like you were referring to some code you saw? Which one was it? Like, do you mean that one?
Move on.
Or do you mean like that?
The loader part.
That?
Later. Load bytes part.
Das ist kein Code mehr.
There is no code anymore. I mean, like, that's the only two parts where we show codes, like that one and...
Well, the code might have been obfuscated already.
Come on.
So we actually don't get the question?
That one.
This one?
Yeah, to me it looks like the data doesn't seem to actually be anything.
Well, you're actually right. The data is not listed here. It's being prepared externally and loaded into the compiler during compile time. So it's linked to the Flash file, but this part has been omitted.
Ah.
Yeah, but well... yeah. Well, the data, as a matter of course, it's printed in red because it's not written on the slide. It's been prepared externally, which happens to be encrypted and encoded code as a byte array. All right. Are there any more questions? Yes, please.
The random ideas, so are these ideas just how to, I don't know,
Hello? Please wait for the microphone.
doing malware or
Please wait for the microphone.
Well, the question is, are the random ideas, well, can they be used in order to obfuscate the code, if I understand you correctly, or more like to detect malware? Well,
As I said at the beginning, it's some sort of game. So we have the possibility to like obfuscate stuff, to deobfuscate stuff, and you want to know. Sorry. So it's a game to. Sorry. Okay. It's a game just for like, you know, like. Sometimes you just want to have the possibility to detect that. Sometimes you just want to have the possibility to just hide it. So that's the basic thing. So if you do some, for example, pen test or whatever, where you think you would like to use Flash in the way that nobody's easy like detecting, or if you really want to attack someone or whatever, there are lots of uses for both sides, in my point of view. So. The random ideas,
yep.
Especially, I mean, like, one of the most interesting stuff, in my point of view, is like the whole, like, UDP stuff. I mean, like, actually, the possibility to have like peer-to-peer functionality inside a browser is like amazing, you know. And that, like, no matter what, I'm quite sure that Flash will like. Continue to be one of the major like sources for supplying like deep exploits, like technology which will be used for planning exploits and stuff. So that's basically ideas. Just play with it and just find out about it and just get it detected in some ways and stuff like that. So it's like random ideas, you know. And on some parts we're already working, on some parts we didn't do anything, but we're just discussing it with some guys. For example, the idea of overwriting the byte loader functionality to just actually trace what's happening in the player, like getting a controlled execution of Flash. That's something which is really, really missing. Yeah? There is nothing like that, at least not available for public use.
If I could just interject for a moment. Everybody on this side of the room, if you could please keep your conversations down so that the people in the front of the room can hear and participate. And if you do decide to leave, please leave as quietly as possible. If you see a bottle, take that with you. Thank you.
Okay, are there any more questions?
Yep. Did you think of using the statistical approach to distinct perhaps ads from regular Swift files? So you can...
That actually works quite well for like banner ads, for example. Or what you mean?
Yeah, banner ads.
I mean, like, what I wanted to show was like this one thing showing the versions, for example. Yep. That's the reality of Flash out there. So most of the files are like ActionScript 2, and most ad files are like something like Swift version 6 with like some very, very basic redirect. And but the main problem is that sometimes those banner ads look like malware because they are just redirects. If you click on it, you get redirected to another domain or to another like location.
Yeah,
but
hello? Can I have the microphone switched on, please? Okay. Unfortunately, Flash banner ads mostly are Flash lower or equal to version 8. And we're trying to analyze this part here, this tiny part, which is ActionScript 3 or more. And in order to apply the statistical classification, you need data, lots of data, and there is not much data in there. It's possible to use statistical